quadrocopters are powered by one of the most extraordinary artificial intelligence networks on the planet. Right now, 4 mini choppers are in training for a slalom course test. We've set out the slalom poles. What are you going to get the quadrocopter to do?
It will fly the slalom a couple of times above the poles, learning, much like an Olympic slalom skier, it has to learn this first.
Right.
It'll do this through repetition. It will fly the course a few times, and once it can fly the slalom accurately, it will drop down and fly the slalom full speed ahead.
Packed with the latest in microprocessor technology, the quadrocopter is programmed with a unique learning algorithm that's linked back to a central computer. And you can see it's tracking here on the screen the path it's taking.
Exactly. Here we can see that were it trying to fly through the poles, it would be hitting them. As it flies a slalom trajectory, it records its position 50 times per second. This information is then sent back to the algorithms in these computers. And at the end of each attempt, it looks at where it was and where it should have been. And then the next attempt, it compensates for this error.
This is the intelligent feedback loop at work. Having learned the course, it's time to put the tech to the test. Now it's dropped down, so it looks like it's ready.
Yeah, it's ready to go, Jim.
Perfect, and you can see its track here. It's learnt.
It's beautifully through all of the poles.
Once the first machine has cracked the challenge, it can transfer its knowledge to other ones that have never attempted it. No trial and error needed for them. They can do the slalom perfectly, first time. Now that's impressive. Not only do these quadrocopters learn by experience, but they can then immediately share that information with all the others. The processing is so fast, they can learn highly complex tasks far quicker than humans will ever be able to, updating their decisions based on the decisions of the others. But how will this technology cope with a highly complex task like balancing an object? Dr. Raffaello D'Andrea is the project leader.
So, Jim, I got a task for you. See if you can balance the stick on your finger.
Okay. Now, I'm normally quite good at this. This is a challenge for even a moderately coordinated human. Of course, it takes a lot of hand-eye coordination.
Yeah, there's really 3 things that are going on here. First, you have to observe the stick. You have to process the information as to what you're going to do, and then you have to move your hand to actually balance the stick.
Now, that's a lot of processing power. The quadrocopters do, I admit, a better job than me balancing the stick. But can they go further and do something I probably couldn't do at all? Does this intelligent feedback loop give them the ability to throw the stick to each other? Wow! That's incredible. How are they doing that?
There are 8 cameras mounted on the ceiling which serve as an indoor GPS system. That information is then sent to several computers. Commands are then sent to the vehicles at a rate of 50 times per second. The vehicles then execute those commands internally at 1,000 times per second. So the complete loop takes about 20 milliseconds to execute. From sensing, figuring out what to do, and then sending the information to the vehicles to decide what to do.
So that's 10 times faster than a human could do it.
That's right, at least 10 times faster, if not a couple of 100 times faster.
But the important thing to point out here is that they're not being remotely controlled by a human operator.
That's correct. The system is fully autonomous. In fact, it'd be impossible for a human being to even fly the vehicle to balance the stick, let alone figure out how to throw it up in the air such that another vehicle can move underneath it and catch it.
Wow! So the machines can pass a stick from one to the other. But what if you introduce an unpredictable factor, something that they're not in control of? In the next test, the high-speed processing and information sharing will need to calculate the trajectory of an object that's thrown at random and then make decisions about how to act.
So here you go, Jim. Just go ahead and throw the ball roughly, in the area where the vehicles are, and they should be able to intercept it and catch it.
Okay.
Wow. Oh, nice one.
Nice one.
And what they'll do now is they'll come a little bit closer and attempt to throw it back to you.
Throw it back to me.
Yeah.
Very good. So what is this demonstrating?
So what you're seeing is something that clearly one vehicle could not do on its own. So they're working together to achieve a very cooperative and dynamic task. They have to work together, otherwise the net couples them. So they could, you know, one could pull the net in one direction, one could pull the net in the other.
And the quadrocopters can take it one step further. They can actually throw the ball to each other with pinpoint accuracy. As proof of concept, this is mind-boggling. Machines with decision-making capabilities that are faster and more accurate than ours. Are we finally entering a new era?
And when do you think this sort of technology might start to make an appearance in our everyday lives?
I mean, slowly but surely they've been making an impact now, but I think you will see that accelerate simply because we have the capability now to network all this knowledge. So I think you will see the network effect increasing the capability of these machines.
So we're talking about the next few years, basically?
I think so, yeah.